Hello my friends, and thanks so much for joining us back to the Galaxy YouTube channel. I'm Dan King, the Director of Media, and today we are at the Advanced Semiconductor Manufacturing Conference in Saratoga Springs, New York. And we have a special treat for you today. We are joined by François Bergeret from Epon Innovations, which since 2022, about Marchish, they are been a part of Galaxy. So François, thank you so much for joining us.
Thank you.
So François, tell us, what has it been like working with Galaxy for the last couple of years now?
Okay, I'm very happy to be with Galaxy now because I believe we are really complementary. There is a lot of synergies between the team. Galaxy is very strong, of course, in software, industrialization, marketing of the solution, and we are more R&D company. So clearly the synergy is there, and the teams are working very well together in France and here in the USA. So that's a very good thing for Epon. For sure.
Well, I can tell you from the other side, we've loved having you too, because having a brain like yours is just second to none.
Okay.
So François, tell me, how does someone who was a University of Toulouse teacher end up starting a business in the semiconductor industry?
Okay, in semiconductor industry, there is a lot of data and a lot of challenges, of course. I was also working at Motorola, and one of the challenge was zero defect initiatives, okay, and difficult to screen the die. So we start to develop PAT and this kind of techniques, and we continue now with Galaxy, with Patman and GAT and this kind of multivariate algorithm.
So was it a smooth transition from teaching to running a business? Now you're doing the same core concepts, but was it a different skills you needed to have for that?
Yes, of course. But the transition was okay because when I was working in Motorola, I was also a teacher. I was also teaching at the university, so the transition was okay.
So François, you mentioned the different algorithms you worked on and PAT. For people out there that don't know what that is, or why is that valuable to the semiconductor industry?
Okay, so PAT is very important. It's a statistical screening. You detect outlying dice and you remove these dice because there is a big probability that these dice will fail in the application, especially automotive application or space application. So it's really because the semiconductor industry needs to go to zero defect that we remove good dice. So it was a very important initiative at the time of Motorola, and now we are improving it with a multivariate algorithm called GAT within Patman in Galaxy.
So what would you say to someone that says, why should I get rid of yield? I thought I'm supposed to be saving yield. What do you say to those naysayers?
We lose yield with this, of course, but this is a price for quality. And on the long term, you remove bad dice, okay, but you find a root cause of these outliers, okay, and you improve yield, and moreover, you improve quality. And companies like Toyota, for example, it is key for this company.
Yeah, and you mentioned Motorola, Toulouse. I actually was a product engineer at Motorola in Phoenix, and when we would get returns back, let me tell you how much money it cost us, how much time it cost us. You have to run around, get the parts tested, take them off the board, go down to the tester, take them out, put them into failure analysis, figure out what caused that failure to happen. Losing a little bit of yield, usually less than 1%, is way less costly and much more efficient than waiting till it got into the final product and fails then, right?
Absolutely, I fully agree with you. Okay, there is an important cost for failures, okay, in the application of the customer, of course. On the long term, high quality companies are the winners, for sure. And right. PAT and statistics and GAT and Patman are very helpful for that. I'm convinced about that.
And François is very humble. For those of you out there, he's a big reason why PAT is even existing in the world. And he's been a huge proponent of this. So he would never say that himself. So I got to pump him up for you guys. So François, tell me, what has been or is the biggest challenge that you've been tasked to basically fix in your professional career?
Okay, one of the recent challenge clearly is the amount of data that we have, that we receive. For example, in semiconductor, we receive a lot of data from process tools, okay? And these data are time series, so you have thousands of points for each run, you have hundreds of sensors, and you have hundreds of runs. So this is a very big amount of data, and we need smart algorithm to get the key information and the key signal from this data. And what is nice is that we have the same problem, the same challenge in other industry. For example, in France with nuclear industry, they have tons of data since years and years and years, and they try to use this data, and also in airplane and space industry.
Now, what is it about the multivariate way of doing things that helps you attack this big data that other ways can't do?
Yes, absolutely, absolutely. I think now it's mandatory to go to multivariate analysis, because imagine if you have, for example, just 100 sensors and you do a univariate approach on 100 sensors, so 1% alarm on 100 sensors is something like 70% of alarm, so it's clearly unacceptable. So we need to go multivariate, because with multivariate you reduce the number of alarms clearly.
Yeah, because if you do univariate, you're going to be chasing your tail the whole time, and if everything's noise and nothing's noise, and you can't break through.
Absolutely, absolutely.
So François, we're at the ASMC conference. Has anything today that you've seen really struck some interesting thoughts with you? Are there any trends you're seeing? What's sort of like the grassroots level of what you're hearing from the conference?
Okay, I attended the metrology session this morning, and what I see is that there is a lot of presentation related to machine learning and to data. So this is of course very interesting, because in one presentation the presenter say that we reach the physical possibility of measurement on CDs, and so machine learning is useful for now for that. And this afternoon, very interesting session on advanced process control, and a lot of presentation on time series, of course, and functional data.
So when you see other presenters talking about time series, which clearly you understand very well, how does that change? Does it change your opinion at all on what you see, what other people are saying or doing, or different challenges in that time series that you know so well?
Okay, some presentations are not so easy to understand, honestly, but what I can say is that the set of methods that can be used are very different. I see 5 presentations on time series and really 5 different methods. One with neural nets, one with random forest, one other with techniques that I don't understand very well for the moment from Samsung. So very interesting.
So it seems like there's no one way to do it. There's many ways to do it. Now, when you hear these different things, do you try to take what they say and see if you can apply it to what you've been doing? Or do you think, well, wait a minute, I think my way is better, or maybe their way is better than mine? What have you been thinking?
No. Of course, we can learn from the other presentation. There was a presentation with 2 algorithms, one for the shift and one for the drift. And this is very interesting, and maybe we can apply something from this presentation here with you and Galaxy.
François, thank you so much for joining us today. And for you out there, if you have any questions for François, go ahead and put them in the comments below. What do you want to know from this brilliant mind about anything you've heard about algorithms, AI, time series, RMAs, PAT, anything? Let us know in the comments, and we'll make sure that he sees these and he's able to comment back to you. So François, thank you so much for being here.
Thank you.